Hi, everyone. My name is Kyle Yang, Director of AV Engine Dev Team from Fortinet, Canada. Today, I'm going to talk about some APT attacks happened on the South Korea. And there are 80 slides in this presentation. 80, yes. So please bear with me until we get the fun part, right? So here is the agenda. So we start from the March 20th attack from last year, and then go through based on the characteristics. We found the Operation Troy, one mission, and Instar Eagle XP. Those 4 operations we might have heard of, right? But the last 2, Flame and Flame 2. Anyone heard of it, except for, the Flame from Kaspersky? Anyone? Great. So let's get started from the Webher attack. So here is the impact, huge impact. There are 2 parts, from the bank, financial institutions, and the media. You can see that 5,000 employee computers, 57 branches, 6 DB servers. The impact is huge. So what kind of things do those damage? Here is the Wiper case 1. The case 1 is the internal use, the number, so it doesn't mean anything, okay? So the dropper, it's a compile time, it's the orange font, and it's dropped 4 files, agentbase.exe, economy.exe, pr1.temp, arg.exe. So there are 2 kinds of wipers. The first one is for the Windows, the other one is for the Linux, Unix. So let's get started from the Windows one. Okay, so first, it's going to check a file mapping object. If it doesn't exist, and then you create, and then try to kill 2 security process from the antivirus software, and then wipe out your MBR. It's pretty simple and straightforward. Remember, simple, straightforward. Here's the other operation system wipers, 4 different kinds. Except the last one, for the general Linux, they're just delete all the important directories on your system. The other 3 are trying to write zeros on your MBR. So it's just destroy your hard drive. And we found this is not the only case. Here is another one. It's a little bit complex than the first one. It has an injector. So it's just inject the wiper into your running process. This one is different. It has a time bomb. It's preset to March 20th, 3 p.m. And the next is a file mapping object. And the result. Still simple and straightforward. Here is another case. File mapping object, and then kill process. And it also has a time bomb there. March 20th, 2 p.m. You can see on the left, 2013, March 20th, 2 p.m. And then still write the strings to MBR. It's pretty quick, right? Okay, here we may have some questions raised. How those wipers got to the computers? Because the wiper is simple and straightforward. It doesn't have any warm function or self-replicating functions that help yourself to spread within the internet, right? So there must be something we missed. Here. Until I found this, it all makes sense. It's a Webher Spreader. So the dropper compiled a day before the attack. And it dropped two files, two zip files, update.zip and VMS 1014.zip. The VMS init.ini file is actually the variable security management system configuration file. It's an update configuration file. The other one, other download.exe file, is actually the Wiper case 3. Exactly match. So let's briefly introduce to this security management system. It has a central server, and it's managed so many clients. I mean, from the damage, like 5,000 employee computers. So the update will push from the central server to all the clients. Here is the content of this configuration file. There are some important values there. The first is the file version. It's easy to understand this file version. And the real file name. This file is actually zipped in the archive, which is VMS 1001.zip. So that executable file is zipped in this file. Down file size means the zip file size. Okay? And the update date. The file directories means when the client received the update zip file, it will extract the update file into this directory. It's actually stored the actual directory in the registry entries. Here, we got two configuration files. The left hand is abnormal ones, actually the malicious one. The right hand is normal one. So we can see the difference. I highlighted in the red. The abnormal ones are actually modified. The real file size, down file size, and the update date. Only these three, compared to the normal one. So why did it do this? Because it must match the zip file it dropped. So you can see the date matched, 2010 October 14th. And the file size, two file size. Real file size and down file size indicate into the file attributes is the compressed file size and the decompressed file size. So basically, so it's a theory. Basically, it will try to replace those two files exist on your central server. And then when the update happens, they'll push these two into all the clients. So let's see how it do it here. First step, keep bunch of process belongs to the security management systems. And then replace the key data of the central server with ha. So this key value is actually store the URL the central server get update from. So it's replaced with these strings. That means disable the central server to get update from the remote website. So if the central server can get update, that means all the clients can get update. All right? And then delete two files. It exists on this management system, security management system. Update.zip and VMS 1014.zip. Exactly the two files dropped by the dropper. And then drop the files into specific directory. Again, to specific directory. But the binary reversing engineering is just told me a theory, right? we don't really know whether it really works. So I did a test. I built up the central server and then install a client, and then running the malicious file on the central server side, and then launch the update from the client side. You can see that the update is still going on the background. And this configuration file, you can see it's already being replaced. It's pushed from the central server to the client. See, oth-down.exe is actually a Wiper. So let's see the Wiper here. Okay, the Wiper got into your computers. All the computers managed by this security management system. And here is actually a normal executable file used by this security management system. It's a normal one. It's not replaced yet because the update is still ongoing. When the update is finished, the normal application is replaced by the Wiper. For now, it doesn't trigger to run this, but the theory is to replace a normal application used by this security management system. Of course, this security management system will occasionally run this file. And actually, I just wait 5 minutes and then check the MBR. Great. When I found this, I was like, WTF? So, if you think this is the only Webher Spreader, you are wrong. Here is another Webher Spreader. Actually, unfortunately, I didn't get dropper. Maybe it actually don't have a dropper. It's two files: np setup, right? np setup.ini and container.exe. The np setup.ini is the update config file for nlab policy center. The container.exe is actually the Wiper case 1, exactly match. But there is no connections, right? So let's see the content. So it's got connected. So I guess the same theory happened. But I didn't test it because I didn't have the dropper. So let's take a look of the security management system they used. It starts to make sense, right? So what do we learn from this? For the security management system, we should have we should protect our own process. A kill process, it won't happen, right? And implement at least a little bit strong verification during your update. Sorry. So for the companies or organizations, it seems we shouldn't stick on a single security management system because it's a weak point. It actually shows us how they turn off shields into their spears, right? Here. So there are still some questions confusing because as the last one is the same, how those Webher spreaders got onto computers, right? And another thing is, actually there are 3 Wiper cases I showed before, but I just find 2 cases match the Webher Spreader. There's still missing one. So is there any other malware download this one? And the Webher Spreader is actually drop the files into specific directory. What if I install the security management system into another directory? The Webher doesn't work, right? It won't work, never work. There's 3 questions. So before we trying to find more related samples, firstly, we need to see the characteristics in those wipers and the Webher spreaders, right? The common parts, no packer. It may have UPX, but nowadays, who treat the UPX as a packer? Second, file mapping object. Third, time bound. 3 important things. And operation choice. No packer. Similar file mapping object, time bound. It uses HTTP protocol. There's no IRC. HTTP protocol. Share similar payload. Because there are not only one choice case. So, for example, there are 6 cases. They are share similar payload and have PDB file path. That's the choice name came from. Try case 1. Start from a downloader and then a dropper. Based on different operating system, you drop different files. Basically, you either drop the true payload or drop an injector or a privilege escalator. Here's another one. Based on different operating systems or 32-bit or 64-bit, drop different files. So when you check the compile date, it's 1 month before, at least 1 month before the attack. So let's see the payload. File mapping object. And then query the 3 registry entries to calculate the ID using the HTTP request. There also string is encrypted, so I just showed the decrypted one. Time bomb. I think it's nothing to explain here. Communication part. Request patterns. No equals 0. ID calculated by the register entry queries. And the SN is a random number. SC is equal to MD5 sum plus 2 ID and 2 SN numbers. And we write server response to this temp file. Try to remember this file name. Decrypt the file using RC4 algorithm and the key. Still simple. Here's the commands. Wake up, easy to understand. Wake up the children. Interval, set the interval that the children connect to the CNC servers. And download exe, download the file and execute it. Map FS, this one is interesting. It will try to write all the file information into one single file and store on your local hard drive. And then might use the upload command to upload this. This may be the answers to that questions I raised before. Maybe the computer just got this choice and then download other Wiper, not spread it by the Webher Spreader. And how they know you install the security management system into that directory? MapFS. They got all your files information, file paths. They knew it. And the last part is a PDB file path. I highlighted the two commands, upload and mapfs. Save me lots of time. Here, characteristics, file mapping object, time bound. Sub4 is actually the string encryption algorithm. Calculate ID is to correlate the three register entries to calculate the ID using HTTP request. And the HTTP request patterns, and RC for encryption decryption algorithm using the communication. Here is an interesting case, Troy case 7. You may notice the compile date is actually after the Wiper attack, 3 days after. Have we received any report that after the March 20th, there are other organizations or institutions got their hard drive destroyed? No, right? So let's see how it works. File mapping object, but the pattern changed. Global / resource share, and it's the same thing. Calculate ID by querying the three register entries. Here is quite different with other Troy cases. The HTTP request pattern is different, and the server responds to another file, the creating file using RSA. Using UDP protocol to get URL list, another list, and use HTTP protocol to get more files. And then, YPO, MBR, and BBRB is 0. There's no strings, 0. And the compile date is 3 days after the attack, March 20th. Here is another question, is like, if some organizations or institutions got their hard drive wiped after the Wiper attack, they should report it. Or they can't report. So what kind of organization and institutions can report those kind of attack? I'll share my opinions at the end of the presentation for this question. Here, Troy case 7 payload characteristics. File mapping object. The string encryption is using XOR with the first byte. Calculate the ID, the same with other Troy cases, HTTP protocol and UDP protocol, and using RSA key 1. You can remember key 1. It's just like a tag, key 1. So, is that all? Operation mission, share similar things. No packer, similar file mapping object, time bound. HTTP protocol and IRC channel. The last line is the PDB file, a part of a PDB file path that the name came from. Here's the mission case. Yeah, the Jopper nlab update kit. So you can see the compile date, 2002. Interesting. Do we still remember the Webher Spreader for the Y-Robot security management system? They modify the compile date to match the update file. So here is the same. The actual payload is unlab update.exe based on 32-bit or 64-bit. It drop different things. But the actual function is similar. File mapping object using global resource share. The same, not same, similar to the Troy case 7, but have different operation name. Calculate the ID using HTTP request. Communication, similar. It's just image equal to 1, and write server response to a random temp file. Decrypting file using modified base 64 and RSA. The protocol is HTTP and IRC channel. The commands, except the HTTP commands, there are IRC functions there, so they can change nickname, they can join IRC. Oh, actually, the command is using integer from 1000. And the function is similar to the Troy case mapfs, upload, download, report. Characteristics. There are two right part new in this mission, operation mission, except the file mapping object, calculate ID, HTTP protocol, they're using IRC channel, base 64, and the RSA key change to key 2. Okay? And the string encryption use XT. It's still not the end. Operation 1 mission, similar is the mission. No packer, similar file mapping object, time bomb, HTTP protocol, IRC channel, similar payload. It's a part of PDB file path. That's the name came from, and it has a version number, 2.1. His chopper is similar with the Troy cases. Actually, do nothing new. And this one more straightforward. There's no injector or privilege escalator. It's just based on 32-bit or 64-bit, it drop the actual payload. This one is much more complicated. Not only 32-bit or compared to 32-bit or 64-bit, they also get the version number, specific version number. One mission payload communications. Patterns similar to the Troy case. And the ID here, they start with 2 strings, and then calculate after that whether either it's calculated by query the 3 registry entries or your MAC address. So here you may read some other vendors' report. If they put those IDs in their report, they're actually the MAC address after that. So you may tell whether they analyze the malware in the virtual machine or real machine. And then write the server response to this file name. The same as the Troy case. Decrypt the file using base 64 and RSA, using HTTP protocol and IRC channel. There are 28 commands. There are too many commands, but the function are the same. Upload, download, report, mapfs. Here, one mission payload characteristics. File mapping object. The new is the mapfs. As a string. String is actually a zip password. Before they just collect the data and then send to the remote server without any compression or encryption. This time they compress it and then send it. And here is the new one, the base 64 and the RSA key 0. Try to remember this key 0 using in one mission. Here's another operation in star. Share similar things. This is the first time we found bsdel.pdb. This is important. Based on this, we can find more things. Version number 2.1. Same as one mission. Also same with one mission. And based on those characteristics, we find another operation equal XP. There has much more similarities. No packer, similar file mapping object, time bomb, HTTP protocol, and IRC channel. Version 2.0. So we can clearly see it's a development path, since it has a version number 2.1, 2.0, 2.0, 2.1, 2.1. Here, similar to the N star, to the one mission. Characteristics almost the same. So here, the Troy case is actually not happened on 2013. The prototype is actually on 2009, the core payload. And it connected all the operations equal XP 2010 and start 2011. Sorry. Mission 2013, one mission 2012. Here. I just, when I get those, I just can't believe it's the end, because it's from 2013 all the way back to 2011, 2010. I just can't believe it's the end. So before we trying to find more samples, we still need to find the characteristics all those operations have. File mapping object, string encryption, calculate the ID using HTTP request, HTTP request patterns. The patterns may change, but HTTP protocol, base64, RSA encryption, IRC channel, mapfs, and then a zip password. How we found this? Operation Flame. The version 1.0 is compiled on 2007, March 7th. It's the very first version of all those operations, very first one. It uses HTTP protocol. And when the Joy got the data from the server side, they just unzip it. So the communication protocol is using HTTP and then zip files passing around. And it has an architecture that has plugins. So it has rootkit, USB dumper, mapfs, keylogger, email stealer. And Operation Flame 2.0, version from 1.1 to 5.6 during the year 2008. It's actually start from pure IRC channel. There's no HTTP protocol in it, pure IRC. And then at the late development, they shift from IRC to a combination of HTTP protocol and IRC channel. It's also reflect that in the other operations, HTTP or IRC channel. And the interesting strings, Army class, Navy Logicom, MND job. Still remember the RSA key 0 using in the other operations, right? The strings is interesting. It's actually told us their targets also use those strings as the IRC channel name. They would join those IRC channel and then send information through those IRC. So the Army class, let's see, the Army class represents the Korean Military Academy. So the Navy Logicom is military parts and supplier. MND job, Ministry of National Defense. You think those are all the targets? No. In the late of its development, target changed a little bit. Military Engineering Department, Korean Military Academy, ROK US Combined Force. So when the target is clear, the next questions will be, what are their purpose? Steal sensitive documents, disable your system. How they steal your sensitive documents? Because the Operation Flame or Operation Flame 2.0 has ability to upload the files. Similar to the Troy case, you still remember that MapFS it will write all your file information into one single file and then send to the CNC server side. It would just try to search things, search some sensitive documents, and then trying to specifically put their paths there and then upload the file from your computer to the remote side. You can't hide anything from the MapFS. Another interesting thing is actually in the late of its development, it tried to identify whether the infected system is AR system. So here, what is an AR system? It's an action required system. It manage all your digital assets and also your digital IDs. So they are not only interested in your digital things. For example, the digital ID. You may enter your facility using an access card. Actually, they're targeting those systems. So use your imagination. But for now, I'll use mine. One way, put the raw ID into the system and then grant an access card. So that means you can enter the facility physically. So your target is not only interested in your digital document, but also interested in entering your facility. Another way is to grant the access to someone already in this facility. If you have an access card, you don't have a right to enter, for example, a server room, right? They maybe give that person in the facility that right to enter the server room or enter some office, because not all the documents are digital. Here, I found so many PDB file paths through all the core payload BS style. So we can first see the red part. It's all written in Korea and then translate into English. It's the right part. Backdoor, work, plan. And when we see the green part, 14, 15, 17, 18, it's a long way development path. And the yellow part, it might be the computer name, or the real person's name, or nickname. Now I'm happy. Really happy. Here is the data paths of all the core functions, core payload, bs.dll. It starts from 2007 along to 2013. you may find interesting things like in 2008, there are a branch there, and then one branch to continue to develop the Flame 1, and another branch to Flame 2. And then they suddenly decided to merge two branches into one, and then 2009. Because the space is limited, I have to combine some similar payload into one block, like the BSK's F1211 at the end of the year 2009. And here I highlight the operation name. There are one for each year. Flame 1, Flame 2, Troy case. Then Eagle XP and Star, one mission, and a 2013 Troy case. Yep, I think that's all. Any questions? Oh, by the way, this is my business card. Any questions? No? Sorry, what?
How long do you take?
The whole investigation, how long it takes? Because I'm a part of my job is dedicated to the engine development, so I have a limited time to going deep into this research. Actually, it's started from last year, March 20th, until 1 or 2 months ago, before I submit the proposal to the Black Hat. It's a long way, and then because the reason I going so deep because I also I ask myself so many questions, so I can continue to find something interesting, and then share with you guys. Anyone? Yep. Actually, you may read of other vendors report, say the hack teams or anonymous team behind this, but I wouldn't say anything about who's behind this because I don't have solid evidence to show who's behind this. Because it's a paradox, right? You just like it's like ask anonymous who you are. Anyone? No one? Okay, thank you guys.